Every day, we interact with structures that seem to defy gravity. Towering skyscrapers pierce the clouds, graceful bridges span vast rivers, and intricate tunnels burrow beneath our feet. But how often do we pause to consider the ingenious engineering that makes these marvels possible? Structural engineering, often hidden beneath the surface, is the backbone of our built environment. It's a field that blends creativity, precision, and a deep understanding of physics to shape the world around us. Imagine holding a skyscraper in your hand, not as a miniature model, but as a digital representation, its every beam, column, and connection laid bare. Advanced visualizations and 3D animations are revolutionizing how we understand and interact with structural design. These tools allow us to peer inside these complex systems, revealing the intricate interplay of forces that keep them standing. We'll witness the power of stress analysis, where vibrant colors dance across a virtual structure, revealing points of tension and compression. Load distribution simulations will demonstrate how weight is transferred through a building, ensuring its stability and safety. Through these captivating visuals, abstract engineering principles become tangible and comprehensible. Structural engineering is not a solitary pursuit, it's a symphony of expertise, where architects, engineers, construction workers, and countless other professionals collaborate to bring a shared vision to life. We'll hear from the leading voices in the field, individuals who have pushed the boundaries of design and left their mark on the world's skyline. Through their personal stories and insights, we'll uncover the driving forces behind their passion for this field. What inspires them to create? What challenges have they faced? And how have they overcome seemingly insurmountable obstacles? Their experiences will provide invaluable lessons about innovation, perseverance, and the importance of teamwork in achieving ambitious goals. Our journey into the minds of leading structural engineers and architects begins with those who dare to dream big, the visionaries who envision structures that seem to defy the laws of physics. These are the individuals who push the boundaries of what's possible, constantly seeking new ways to elevate, span, and enclose space. They approach each project with a unique blend of artistic vision and scientific precision. Understanding that form and function must work in perfect harmony, we'll hear from architects who sculpt breathtaking forms with glass and steel, creating iconic structures that redefine a city's skyline. Engineers will share their insights into the intricate calculations and innovative materials that allow these daring designs to withstand the forces of nature. Through their stories, we'll gain a deeper appreciation for the creative spirit and technical mastery that drive these monumental projects. The art of engineering, blending aesthetics and structural integrity. While structural engineering is grounded in scientific principles and mathematical calculations, it also encompasses a profound artistic sensibility. The most successful structures are not simply functional. They possess an elegance and beauty that elevate them to the realm of architectural masterpieces. This inherent artistry stems from a deep understanding of how form, proportion, and materials can be combined to create visually stunning and structurally sound designs. We'll delve into the minds of architects and engineers who possess a keen eye for aesthetics, exploring how they integrate artistic principles into their structural designs. They'll discuss the importance of creating buildings that harmonize with their surroundings, complementing the natural landscape or urban fabric. Beyond the blueprint, from concept to concrete reality. The journey from an architect's imagination to a towering skyscraper or a gracefully arching bridge is a testament to human ingenuity and collaboration. It's a complex process that involves countless individuals, each with their own specialized skills and expertise, working in unison to transform a vision into a tangible reality. Our expert insights will extend beyond the design phase, venturing onto bustling construction sites where we'll witness the transformation of blueprints into concrete and steel. We'll hear from project managers, construction foremen, and skilled laborers who navigate the intricate logistics of assembling these massive structures. The unseen hand engineering solutions for invisible forces. While we marvel at the visible grandeur of towering skyscrapers and expansive bridges, what remains hidden from view is the intricate dance of forces that these structures must withstand. Gravity, wind, earthquakes, and even temperature fluctuations exert constant pressure, testing the limits of engineering ingenuity. Our expert insights will delve into the world of structural analysis, where engineers employ sophisticated software and calculations to predict how structures will behave under various loads and stresses. We'll hear from specialists who dedicate their careers to understanding these invisible forces, developing innovative solutions to counteract their potentially destructive effects. Guardians of safety, ensuring resilience in an uncertain world. In an era marked by increasing climate volatility and the ever-present threat of natural disasters, the importance of designing structures that can withstand unforeseen events has never been greater. Structural engineers play a critical role in safeguarding our communities, ensuring the resilience of our buildings and infrastructure in the face of uncertainty. Our expert insights will focus on the crucial role of safety and risk mitigation in structural engineering. We'll hear from engineers who specialize in designing structures for extreme conditions, from earthquake-prone regions to hurricane-force winds. A legacy in steel and stone, the enduring impact of structural ingenuity. The structures we build are more than just physical entities. They are testaments to human creativity, ambition, and our enduring desire to leave a lasting mark on the world. From the soaring arches of ancient Roman aqueducts to the sleek lines of modern skyscrapers, each generation inherits a legacy of structural ingenuity that shapes our lives and inspires future generations. As we conclude our exploration into the world of structural engineering through the lens of expert insights, we'll reflect on the profound impact these structures have on our lives. They provide shelter, connect communities, and serve as symbols of human achievement. Seeing the unseen, unveiling the forces at play. Imagine holding a skyscraper in the palm of your hand, not as a miniature model, but as a dynamic digital representation. Advanced visualizations, powered by cutting-edge software, have revolutionized structural engineering, allowing us to witness the invisible forces at play. We can now visualize stress distributions, load paths, and structural deformations in vibrant detail. Through 3D animation, we can apply virtual loads to a bridge and watch as the software calculates and displays the distribution of forces. The language of lines and colors, deciphering structural analysis. Structural analysis, once confined to complex mathematical equations and hand-drawn diagrams, has been revolutionized by the advent of advanced visualization tools. These tools translate the language of numbers and formulas into a visual symphony of lines, colors, and animations, making it easier than ever before to understand the intricate interplay of forces within a structure. Imagine viewing a cross-section of a bridge pier, not as a static image, but as a dynamic representation where load paths are traced with glowing lines illustrating how weight is transferred from the deck through the supporting columns and down to the foundations. These visualizations demystify the flow of forces, revealing the elegant solutions engineers devise to distribute weight efficiently and ensure stability. From blueprint to digital twin simulating reality in the virtual world. Gone are the days when architects and engineers relied solely on two-dimensional blueprints and physical models to convey their designs. Today, we can step inside virtual representations of buildings and infrastructure, exploring their intricate details and experiencing how they would behave in the real world, all before a single brick is laid or a beam is hoisted into place. Building Information Modeling, or BIM, software has ushered in the era of the digital twin, a dynamic, data-rich virtual representation of a structure that evolves throughout its life cycle. This digital replica incorporates not just geometry, but also information about materials, construction sequencing, and even the building's projected energy performance. Stress, strain, and simulation. Understanding material behavior. Materials are the building blocks of structural engineering, each with its own unique properties and behaviors under stress and strain. Understanding how different materials will respond to various loads is fundamental to designing safe and efficient structures. Advanced visualizations have become indispensable tools for visualizing these complex material behaviors, providing insights that go far beyond what traditional equations and graphs can convey. Imagine applying a virtual load to a steel beam and watching as the software simulates its deflection, displaying the bending moment diagram and highlighting areas of highest stress. We can observe how the material deforms under tension and compression, gaining an intuitive understanding of its elastic limit and ultimate strength. The choreography of construction, visualizing complex sequences. Constructing a skyscraper or a bridge is a logistical ballet, a carefully choreographed dance of heavy machinery, skilled labor, and precisely timed deliveries. Advanced visualizations have become invaluable tools for planning and managing these complex construction sequences, providing a virtual rehearsal space where potential clashes can be identified, timelines can be optimized, and communication between stakeholders can be streamlined. Imagine viewing a time-lapse animation of a bridge construction project, where each stage of the process, from the assembly of temporary scaffolding to the placement of prefabricated segments, is meticulously planned and visualized. 4D simulations, which incorporate the element of time, allow project managers to track progress, identify potential delays, and ensure that materials and equipment arrive on site exactly when needed. A window into the future. Predicting performance. Enhancing design. As technology continues to advance at an exponential pace, the future of structural engineering is being shaped by the growing power of visualization and simulation. We are entering an era where we can not only visualize how structures will behave in the present, but also predict their performance decades or even centuries into the future. Optimizing designs for longevity, adaptability, and minimal environmental impact. Imagine using artificial intelligence and machine learning algorithms to analyze vast data sets of structural performance data, identifying patterns and predicting potential issues before they arise. Sensors embedded within buildings and bridges could provide a constant stream of information on temperature, vibration, and material fatigue, allowing for proactive maintenance and ensuring the long-term health of our infrastructure. Groundbreaking, where vision meets Earth. The journey from a blueprint to a towering skyscraper or a gracefully arching bridge begins with a powerful symbolic act, the groundbreaking ceremony. This ceremonial first dig into the earth marks the transition from the world of ideas to the realm of physical reality. It's a moment charged with anticipation, where architects, engineers, construction workers, and community members gather to witness the birth of a structure that will soon grace their skyline or connect their communities. Our cameras capture the energy and excitement of these groundbreaking events, where shovels plunge into the earth, unearthing the potential for innovation and progress. We see the smiles on the faces of those who have poured years of planning and dedication into this moment, their dreams taking shape before their very eyes. Once the groundwork is laid, the construction site transforms into a hive of activity, a symphony of coordinated movement, clanging metal, and the rhythmic pulse of heavy machinery. Massive cranes, their arms reaching skyward like steel giants, lift beams, columns, and prefabricated sections into place, assembling the skeletal framework of the structure with astonishing precision. Our cameras capture the balletic grace of these mechanical marvels as they hoist multi-ton loads with ease, their operators demonstrating a mastery of leverage and balance. We witness the intricate dance of coordination between crane operators, riggers, and signalmen, communicating through a language of hand gestures and radio chatter, ensuring the safe and precise placement of each structural element. Behind the scenes of every successful construction project lies a hidden world of intricate logistics, a carefully orchestrated dance of materials, equipment, and manpower. The smooth flow of these essential elements is crucial to maintaining momentum, minimizing delays, and ensuring that the project stays on schedule and within budget. Our cameras venture beyond the construction site itself, following the supply chain that feeds this insatiable appetite for materials. We witness the arrival of convoys of trucks, their flatbeds laden with steel beams, concrete panels, and other prefabricated components. Each piece meticulously labeled and destined for a specific location within the emerging structure. While heavy machinery dominates the early stages of construction, it's the skilled hands of craftsmen and women that bring the finer details to life. From the welders fusing steel beams with fiery precision to the masons laying brick by brick, these individuals combine traditional craftsmanship with modern technology to create structures that are both functional and aesthetically pleasing. Our cameras zoom in on the meticulous work of these skilled tradespeople, capturing the artistry and precision of their movements. We watch as welders don their protective masks, their torches igniting with a shower of sparks as they join metal with an accuracy measured in millimeters. We see the steady hands of electricians carefully threading wires through conduits, their work hidden within the walls, but essential to the building's future functionality. Innovation on site. Pushing the boundaries of construction practices. The field of construction is constantly evolving, driven by a relentless pursuit of efficiency, sustainability, and innovation. New materials, technologies, and construction techniques are emerging all the time, pushing the boundaries of what's possible and reshaping the way we build the world around us. Our cameras document these innovations in action, showcasing how cutting-edge technologies are being integrated into real-world construction projects. We see drones equipped with high-resolution cameras surveying vast construction sites, creating detailed three-dimensional maps that aid in planning and monitoring progress. We witness the use of self-leveling concrete, which spreads evenly without the need for extensive manual labor, accelerating construction timelines. A global tapestry. Structural engineering around the world. The principles of structural engineering are universal, but their application varies widely depending on local context, cultural influences, and available resources. From the towering skyscrapers of New York City to the bamboo scaffolding of Hong Kong, from the earthquake-resistant buildings of Japan to the floating homes of the Netherlands, structural engineering takes on a unique flavor in every corner of the globe. Our cameras travel the world, capturing the diversity and ingenuity of structural engineering projects across different cultures and continents. We witness the construction of mud brick homes in arid regions, their thick walls designed to provide natural insulation against the scorching sun. We marvel at the intricate timber framing of traditional Japanese temples, their interlocking joints designed to withstand earthquakes and typhoons. The rise of intelligent structures. Embracing the AI revolution. Imagine buildings that can anticipate and respond to their occupants' needs, bridges that monitor their own structural health in real time, and cities that optimize traffic flow and energy consumption based on dynamic data analysis. This is the promise of intelligent structures, a future where artificial intelligence and machine learning are seamlessly integrated into the very fabric of our built environment. AI-powered sensors, embedded within buildings and infrastructure, will generate a constant stream of data on everything from temperature and vibration to occupancy patterns and energy usage. This data, analyzed by sophisticated algorithms, will enable predictive maintenance, identifying potential issues before they escalate into costly repairs and optimizing building systems for maximum efficiency and comfort. Building with nature. The promise of bio-inspired design and sustainable materials. For millennia, nature has served as the ultimate inspiration for architects and engineers. From the soaring arches of Gothic cathedrals, inspired by the branching patterns of trees, to the aerodynamic forms of modern aircraft modeled after bird wings, we have long looked to the natural world for elegant and efficient design solutions. In the future, this bio-inspired approach will become even more prevalent, leading to structures that are not only aesthetically pleasing, but also inherently sustainable and resilient. Biomimicry, the practice of emulating nature's forms, processes, and ecosystems, will inspire a new generation of structural designs. Imagine buildings with facades that adapt to changing light conditions like a sunflower following the sun, or bridges whose structural elements are grown rather than manufactured, using self-assembling materials inspired by seashells or spider silk. Adapting to a changing world. Engineering for resilience and flexibility. In an era of climate change, rising sea levels, and increasing urbanization, the structures we build must be able to adapt to a rapidly changing world. The future of structural engineering will be defined by resilience, flexibility, and the ability to withstand both predictable and unforeseen challenges. Buildings will become more than just static containers. They will evolve into dynamic systems capable of responding to changing environmental conditions. Imagine skyscrapers that can adjust their shape to mitigate wind loads, or bridges equipped with sensors that monitor stress levels and adjust tension cables to maintain stability in high winds or earthquakes. The human element, nurturing creativity and collaboration in a tech-driven future. While technology will undoubtedly play an increasingly important role in the future of structural engineering, it's essential to remember that this field is ultimately about people. The structures we build are not just feats of engineering. They are expressions of human creativity, ingenuity, and our desire to create a better world. As AI and automation take over routine tasks, it will be more important than ever to nurture the human skills that are essential to innovation and problem-solving. This includes fostering creativity, critical thinking, collaboration, and communication skills, as well as a deep understanding of ethical considerations and social impact. Reflections on innovation, a legacy, etched in steel and stone. Innovation has been a resounding theme in structural engineering. From mud brick structures to today's skyscrapers, humanity's quest to build bigger and bolder has been constant. Visionary engineers and architects have consistently pushed boundaries, reshaping our planet's landscape. We've explored materials from stone and timber to steel and bio-based composites. Each innovation opens new possibilities, allowing us to reach greater heights and span wider gaps. Roman architects harnessed the power of the arch, and medieval builders perfected Gothic cathedrals, leaving a lasting legacy. The power of vision, from imagination to reality. Vision transforms ideas into structures that shape our world. Every skyscraper, every bridge, every tunnel began as a spark of imagination, nurtured by architects and engineers. They blend artistic sensibility, scientific understanding, and a drive to turn dreams into reality. We've seen the collaborative process, the interplay of creativity and technical expertise. From initial sketches to 3D models, each stage brings the project closer to fruition. Architects sculpt space with light and shadow. Engineers calculate load and stress, culminating in structures that are stunning and sound. Shaping our future. The enduring impact of structural engineering. As we conclude our exploration of structural engineering, one resounding truth emerges. This field is about far more than just bricks and mortar, steel and concrete. It's about shaping the future, creating the spaces where we live, work, learn, and connect as a society. The structures we build today will shape the lives of generations to come, influencing how we interact with our environment, how we build communities, and how we define our place in the world. The future of structural engineering is brimming with exciting possibilities. Artificial intelligence will revolutionize design processes, enabling us to create structures that are more efficient, resilient, and responsive to their occupants' needs. Bio-inspired design and sustainable materials will lead to buildings that exist in harmony with nature, minimizing their environmental impact while enhancing the well-being of those who inhabit them.